Hi there guys, I'm Chris Bowden.
And I'm Paul Kidwell.
Welcome to the Geek Group. We're here continuing this is part 2 in our two-part series on the not a Geiger counter.
Correct.
Now this is all about the Japan earthquake radiation stuff.
Yes it is.
Okay, so Phil, teach me about this. What do we got?
All right, from the last video, we did the hardware to interface our survey meter into our Arduino.
Okay.
All right, and I took a meter to this resistor and found out it's a 10K, just like the other one.
Okay.
So this is our complete circuit. From the survey meter, you go through a little filter circuit here. Is that a high pass, low pass? I don't even remember. It's been a long time.
Depends a lot on the value of the capacitor.
0.1 microfarad, 10K resistor, feeding into the LED part of an optocoupler. So all that is separate from our Arduino.
Okay.
10K pull up to 5 volts, ground the bottom of the photo transistor, and that I/O pin goes into our Arduino.
And the details of how this works are all in the first part, so we've got all that covered. So we don't even need this anymore.
Yes.
Okay.
Right. We can get rid of it.
There you go, because you're going to be writing code.
I'm going to be writing code.
Writing code!
So let's get rid of all that. Goodbye chip. Now the I/O pin, which is this last little bit over here, we're wiring into pin 2.
Pin 2 on the Arduino.
Yes, and they
Okay.
count from 0, so it's like the third socket, but it's 0, 1, 2. Now, pins 2 and 3 are interrupt inputs. Now, when you get a gamma wave or a beta particle in here, it grounds the tube, you get a negative spike.
Okay.
All right, so that's an event. The transition from its normal voltage down is the event that we're going to try and track.
Okay.
All right, now, the Arduino has hardware interrupt inputs. And what that means is you got a pin, and you can monitor that pin so that if it sees a particular condition, and there's like 6 different things you can program there, but when the Arduino sees that, it'll stop operation of its normal program and go run a special piece of code to deal with whatever it is you're trying to deal with. And when that's done, it returns to normal operation.
Now, you mentioned like 6 different conditions. Is there a specific thing that you can only do to that pin, or can it tell that I've gone high, I've gone low,
Okay.
you know?
You can set it to, what you're doing is you're setting when the interrupt is going to trigger. And you can set it to trigger if it sees a high level or a low level. You can also set it for rising or falling.
Oh, wow.
So falling is what we're interested in because it's that negative pulse. It's going to go from high down to 0.
Now, why would we want falling as opposed to
Because the
low level?
normal state, because it's, okay, in theory low level would work as well, but it's the transition from high to low. If your pulse duration is longer than the time it takes the interrupt to process, you'll get 2 interrupts.
Okay.
Because the low level will still be low.
Okay.
We're just interested in when it's going from high to low.
Okay.
All right. Now, we're going to count pulses. So we need something to hold that. And here we go. I'm going to write the code right on the board here.
Okay.
And I got it on my screen right here. I mean, that's the whole program right there.
Now, while you write that out, I'm going to keep an eye on the IRC because for those of you that are new to the Geek Group videos and that, we have a new thing. We're able to do live streaming video, and we are streaming this right now, even though you may be watching this on YouTube a week later. At this moment, we're streaming this video live on our Ustream account, which you can see right there. And if you are watching one of our Geek Group videos and have questions or something like that, you can ask in the comments if it's on YouTube. But you could be watching this or any future videos in our Ustream channel. And if you have a question like, you know, about the pin 2 on the Arduino and whatnot, you can ask this in the Geek Group's IRC channel, which is right here. And we're going to be putting that on our website pretty soon as well. That's going to be a whole bundled thing with like an embedded video and the IRC going and all that jazz. So that people can ask questions in the IRC when we're doing the video, and I can just look over here, and there's about 30 or 40 people in there right now, and we can just see what's up. And they're talking about Schmidt triggers and rising falling edge trimmers and triggers and stuff like that. Or if Raylan posts that you can ask about this stuff in the forums afterwards, because these videos all post to the forums in the Geek group, and you can ask questions there. So, okay, do your thing.
All right.
I'm just going to make fun of people.
I'm going to make fun of people.
It's what I do.
I'm going to copy my code right from the
Do you want me to read that off for you? Or?
Not necessarily,
Okay.
because I'm gonna
Because
talk
it's so
about it.
complicated. I mean, you might forget stuff.
Yes. All right. We're going.
And God help you if you forget like a semicolon with this crowd. You have 500 people like, ah!
This code's running. I know it compiles. So
Oh, I know that, but it's writing it up here. If you miss one thing, they're going to freak out on you.
All right. We are going to be keeping track of the count of pulses that we're receiving.
Okay.
And we're going to use a global variable to take care of that. So I'm going to, right up at the top, I'm going to declare a variable here. Count. It's going to be an integer. Count. And I'm initializing it to 0. So I got to equal 0. And here's your semicolon, just so I don't forget it. All right. All right. Let's see. We have the pulses coming in. We're going to want to count them. We're going to need, we're going to use an interrupt. When the interrupt fires, it runs a little piece of code called an interrupt service routine, ISR. So down on the bottom here, I got a really complicated routine.
While you're doing that, I'm going to yell at somebody over here. Okay?
Okay.
Hey, Rob, up there in Master Control. Yeah. Are you reading the IRC? Is there a way that you could spin camera 2 around and have somebody up there zoom in on the board so that the guys in the live stream can read the whiteboard?
I can do it.
Okay.
Okay, we're making real sure we got it done right.
There's nothing in the middle.
There will be.
Okay. Because I'm looking at the overhead of the monitor there, and you've got the whole void loop, int delay, I equals count, Serial.println stuff, and it's not on there.
All right. Here is our interrupt service routine. And the only thing it's doing is this one line, count plus plus, which means whatever count is, increment it by 1.
Okay.
So we're counting. All right. Now, on an Arduino, you have a setup and a loop routine. So we'll put that in. Void. Setup. And you got your opening brace. And we're going to output to the serial port.
Okay.
So I can see it on the little serial monitor over here.
Okay.
And you have to set that up, which is a Serial.begin, and we're going to do 9600 baud. So. All right, next line. I got 2 lines here. I'm going to talk about the second one in a bit, but we're going to use pin 2 as our input. And you set pinMode to 2 comma input to declare that.
It's nuts how many people are watching this
Yeah.
and commenting and like having conversations with the crew while we're doing this. Rob, are you monitoring the IRC?
Yeah.
Okay.
I am too.
Okay. You two stay on top of that and work with them on stuff, and then I'll just read it so I don't have to comment to it on camera. But they did come up with a cool idea that we need to do. And you may need to terminate some cables.
Why is that?
The guys on the IRC came up with a really cool idea.
What's that?
We have the ability to pull an audio and video feed out of these cameras. We run them to the blocking monitors so that we can see what we're doing.
Right.
We've got like 12 inputs in the switcher up there.
Yeah.
Boom, 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 up to the switcher, and we can use these in the live thing.
You have additional outputs on the cameras that you could parallel that?
If we can't pull it right off the camera, I know we can pull them off the monitors that the cameras are feeding, because the cameras feed the blocking monitors, so we could do that.
I was going to have to put a Y in the cable that's coming out from the camera.
You could get impedance issues doing that, but I'm sure we can get the loop outs from the cameras. The only thing...
I was going to say, nobody can just save it and stream it live like we were doing the editing.
Yeah, we could be doing that. And once we get the big switcher going, oh, wow! That could be really cool. And then we can move that camera back, and that's a behind-the-scenes camera. And then we've got these cameras for the real live streaming video. And it's just, oh, it's worlds better. This is great.
Okay. All right. I put 2 lines in here to basically declare pin 2 is going to be our input.
Okay.
And this digitalWrite 2, high, there's a pull-up resistor built into the Arduino. So the resistor that was on this side, on that I/O pin,
We don't need that?
we don't need that.
Okay.
You could literally pull it off the board if you felt. I tried it, and it still works without it because of this line right here.
Okay.
Now, the next line is the important one for our interrupt. And we have our interrupt service routine, and we've declared pin 2 to be an input, but
Okay.
you have to attach the pin to the interrupt.
Okay.
And they have a line that says attach interrupt.
Oh. And the cool thing is we can cut to Paul's overhead video right now, which shows the actual screen he's copying this stuff off of.
Okay, attach interrupt is the function. We have 0,
Hey, Paul.
count ISR, and falling. Yes.
One of the guys on there just posted a thing about PC sound card. Why could you not just take this and hook it to a microphone into a computer and get rid of the Arduino?
Okay, this computer is rather expensive. That Arduino is 30 bucks.
Yeah,
I
but
can put an Ethernet shield on there and have it stream to the Ethernet if I feel like. Which one of
okay,
our members
that's
has
the thing.
done.
Okay, because what I was wondering is you're just using the Arduino to interface to the computer, because hence the
All right.
USB
You
out.
can do a lot more with that Arduino than just interface to a PC.
Okay.
And one of our users, Radioactive, has done something very similar to this using a different type of sensor,
Okay.
and he's got it on the internet.
Okay.
I'm not certain if he's using an Ethernet shield on an Arduino or not, but that's the sort of thing. That
But if you
we're
did,
aiming
if you didn't have the Arduino, you could just do this with a sound card.
There are people that have done that. Yes, you could have the output from the optocoupler feed into your sound card. That's
Okay.
doable. But the software that you're going to use to do that is a lot more complex than this dozen lines we have.
Well, yeah. Okay. Okay. Back to your thing.
Back to
I was just asking. Somebody brought up. I'm like, yeah, that's a good idea.
Okay, attach interrupt 0, comma. I forget what the 0 is for. The next thing is the name of our interrupt service routine, which is count underscore ISR. And then the third item is the condition that you want the interrupt to happen on. Oh, the 0 is interrupt 0, that's right. Pin 2 is interrupt 0, and pin 3 is interrupt 1. So if we were tying into pin 3, we'd have to change that 0 to a 1. That's right, I remember now. Anyhow, the condition that we want to have this routine execute on is the falling edge of our interrupt pin. So we put falling right here.
And then a parentheses space semicolon.
Semicolon. All right. And a closing bracket.
That's what those are called?
Yep.
Oh, okay.
Or brace. I've heard them
I
called
thought
braces.
brackets
are
were
usually
the
square.
that, yeah.
Those are braces.
Oh, okay. I don't know.
Okay. I'm kind of running out of room here. But actually I am running out of room. There's my eraser. I'll put that back in later. All right. Now we have the main body of our program. For an Arduino, it executes setup once, and then we have something called loop, which loops through continuously.
Okay.
And it's void loop, parentheses, open. That's a terrible mess. All right. We're going to have a variable we're going to use inside this loop, so I'm going to declare it here, int I. All right. We're going to count for a second. All right. So right here, we're going to put a delay of 1,000 milliseconds. All right.
Okay.
So when this loop starts, the first thing we do is we wait to allow the count from the interrupt to accumulate.
Okay.
The next thing we do is we capture what that count is.
Okay.
So we can use it a little later in the routine. So we're going to use our variable I equals, and our variable name from up here, count. And then we're going to clear count.
Paul.
This is painful to you, isn't it?
No, the first thing I thought of when I'm looking at this, and you want to know what I'm thinking?
What?
First program I ever learned.
Really?
Yeah.
It's very close. All we're doing is counting.
the for t equals 1 to 1,000,
Print,
20,
you're an idiot.
print t, and then 30 was next t. I was like, delete count, didn't wait 1,000 and do the thing. And like, yeah, I remember this. It was a while ago, but it was back when we were using line numbers and whatnot, but yeah.
What's going on here is, at this instant in time, when the program waits a second, right here, it grabs whatever count is and then clears the count.
Yeah.
Because as soon as that gets set to 0, our interrupt is still firing in the background, whatever we're doing here. So from this point on, the counter is at 0 and it starts counting again.
Yeah.
All right? So here, we're going to actually do something with the count, and all I'm going to do is blow it out to the serial port, which is Serial.println. LN gives us a new line, I.
Okay.
And that's the end of the routine.
So this is send it to the serial port, print, new line, and then whatever I is, the variable.
Right. So this is printing on a new line, and it's just going to output a number.
Yeah.
And that's the number of counts that we've received over the last second.
Yeah.
And I got it set up and running here, and this is my serial monitor, and I have it turned off at the moment, but if I bring it over here, you can see I'm reading zeros. If I put it next to the source,
There's a 1.
there's a 1.
You had a 1.
Should be reading better than that. I think,
Your meter is weak and floppy-like.
oh, there it goes.
Oh, 9, 49, 47, 39, 39,
All right,
40. If it hits 50, sell.
Yes. So right now we're actually getting the counts per second.
Yes.
All right. Now,
That's a hell of a lot of counts per second. We're gonna die in here!
I can take and do I times 60,
And that's your counts per minute.
and that will be
That's your
kind of
CPM. Yeah.
counts per minute. So I'm going to go ahead and do that. Ooh, that was bad.
Ooh, Paul.
What? I can't believe I did that. I'm so glad we have an undo. Oh, Control Z. There we go. Times 60. I believe that works. You put a times 60 inside a print line, you should be able to. And we're uploading to board. What are you doing?
Nothing. Just testing something out. Got an idea.
You should be hearing stuff.
Yep. Okay, take that.
Done upload.
Okay, hold it up there.
Oh, that's good.
Hold it up there.
Oh, God.
Ooh, that's a bad sound. Hang on, oh, that's how I can do it. Okay.
Generally speaking, that's a bad sound.
That is the bad sound that you never want to hear.
Yeah. Especially like when you're waving it over the ground 4 feet above the ground.
It's Christmas at ground zero, and if the radiation's okay, I'll go out with you and see all the new mutations on New Year's Day. I just had to play with that. It just occurred to me, it's like, hey, I can put that up, and you can scare the hell out of people with that.
Yeah.
You just put that on the roof at night. Yeah. Duck and cover.
Take a look at the numbers we're getting for counts per minute right now.
We're all gonna die. Oh, that's counts per hour?
No, that's counts per minute.
We've gone from seconds to minutes. Okay.
That's right. All I did was change that from print line I to...
You know, my meter pegs at 500 counts per. Yeah. Okay. Yeah.
Like I said, the calibration on these is from like 1960s, and when was the last time this guy was calibrated?
But still, the pop, 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 pop. I mean, that's real time. You don't calibrate that. If it pops, that's a particle.
Right.
Every particle is a pop.
Right.
There is no calibration for that.
For this, you're
It's
absolutely correct.
totally binary.
It's based on how accurate a time clock we got. And
Yeah.
we're using a quartz crystal on that Arduino.
Yeah, so,
we're
I mean,
really
it's
accurate on time.
Yeah. I'll put my toy away.
Yeah, 1,620 counts per minute.
Cool.
Anyhow, that's basically how you do it. That's our that's all the software we need
Okay.
to tie this Arduino into our survey meter and actually count pulses. Now, there's guys over in California that have been trying to do this, and this will show them start to finish how to take, this is a...
Yeah, now all the people out there that are interested in doing
CDV
this.
700 and interface it to your Arduino.
And this is something you can get these on eBay or antique stores and whatnot.
Yes, eBay, they're very common.
And this, you can get these anywhere.
Yes,
I mean, it's an
there's lots
Arduino,
of
it's pretty common. And if you're watching this video, you know where to get an Arduino, I'm sure.
I'm quite certain.
What else do we need to cover?
That's pretty much it.
All right, let's see, let's go to the live stream. Do you guys out there have any questions that we haven't covered yet? Let's see if anybody in a live stream has anything. They're talking about they need a heavy water jug,
A heavy water jug.
radon water or something like that. I don't know.
Water.
I'm pretty sure all the people in the live stream are at this point functionally retarded. I don't
No,
know.
they're just totally
Yep.
ignoring us.
No, Magdalene Vin's in there. All right, yep, nobody's any help at all. Okay, so that's it for live stream. They're talking about water jugs and stuff. I don't even know. Yeah. Thank you, Dan. Yes, we love you all.
Total failure on the live stream.
All right, we want to say hi to Magdalene Vin, Electric Guy, Youts, Madman Mark Australia, and Fulzy, and Exor674, and all the other fun guys out there who are in our first official live stream in the video shoot here in the studios.
Hey, we got people from the United Kingdom. They're all over the world.
Yeah.
Mark is from Australia.
Yeah,
Someone's from Australia.
we've got Australia,
Cool.
we've got the UK. I'm like, you know that internet thing, Paul, it's catching on.
You
All
think?
the cool kids are doing it.
Really?
Oh, it's going to be huge. It's
Think
going to be
so?
huge. It's going to be great.
I got it.
All right, so I'm Chris Bowden.
And I'm Paul Cadwell.
We want to thank you for watching along and having fun and learning about codes and bits and particles and
I'll give Moose a copy of my code, not that it's like I wrote it all out.
yeah, it's not that hard.
I'll just reply.
Please remember to rate, comment, subscribe, and donate. It is your donations that make it possible for us to do all this awesome stuff. And if you have any viewer feedback or comments or leave them in the forums, go to thegeekgroup.org, get involved in the forums. There's all kinds of stuff that you guys can do to get involved here. And that pretty much covers it. We're going to be back next time. We're going to be doing some equipment autopsies, having all kinds of fun. But right now, I think the next big project, and the people watching the live stream can follow along, is going to be, because we're all set up for it, we've got the big spool of cable, we've got the BNC ends and all that jazz. Let's run a couple feeds up there so we can get these cameras on the big thing.
Okay.
Cool. All right. You guys have fun. We'll see you next time.
This video was made possible by a grant from the Future Girl Foundation.
This video was made possible by thousands of private donations from members and viewers like you. Please visit thegeekgroup.org for more information on how you can donate and become a part of our dreams of Avalon.